Hello guys and girls. So we have already done the graphing method for solving systems, and we've used the substitution method. So what we're going to work on now is solving systems using the elimination method. And really, I should have put the word right here. We're going to be solving linear systems, and we're going to be sticking with that for this unit. So we're only considering systems of linear equations. Let's talk about another way to solve these. But before I do, let me just emphasize, the only reason I'm giving you these 3 different ways to solve systems is because in certain situations, one particular method is going to give you an advantage over another, and that's a topic for conversation later on in the unit. But just to keep in mind, why we even bother? Why is just one way not good enough? Well, some equations lend themselves nicely to elimination, and they don't really work well in other situations. So let's take a look at a few examples. So there's only 2 examples. Here's example 1. So elimination is kind of interesting because it has us do some things with equations that we're not used to doing. So first off, let me show you that you can multiply everything in an equation by the same number and it won't change the value. So take a look at this simple equation here with me. So 5x equals 10. If I asked you, hey, what's x? You'd say, well, x must be 2, right? Because 2 times 5 is 10. Well, let's multiply everything in this equation by, well, I don't know. Let's multiply everything in this equation by 5. So we get distribute it. So we get 15x equals 30. So what's x in the new equation? Oh, well, it's still 2. So why did I show you that? I showed that to you to basically make the point that you can multiply everything in an equation by the same number, in this case 3, and it won't change the value of the variable, or it really won't mess with your equation in a significant way. So we can use that to our advantage when solving systems. Remember, if we have one equation with one variable, we can solve it. That's why we use the substitution method. So we can get one equation with one variable. So what I'm going to do is I'm going to first look at both of these equations here, and I'm going to try to identify either the y term or the x terms. So which one of these terms am I going to try to eliminate by adding the equations together? So you can also add 2 equations to each other and get a new equation that still works for that particular system. So there's a lot of new stuff coming at you here, okay? So in this particular example, if I was to just add these equations, let's just say I was just going to add them together, this is how you would add 2 equations. You would go term by term. So negative 19 plus negative 19 would be negative 38. Y plus 3y would be plus 4y. And then negative 7 plus a negative 2 would be negative 9x. So we get a new equation, and this equation, it works in our system and with our system. But it didn't really help us, right? I just added them together, and it hasn't helped me because I still have one equation with 2 variables. So the question is, can we multiply one of these 2 equations, one of these 2, by a number and then add it together, thereby eliminating one of the variables? Let me show you what I mean. Let me erase all this stuff here. So the first thing I'm going to do is I'm going to multiply the top equation by negative 3. So I'm going to pull that top equation down here, okay? Negative 7x plus y equals negative 19. I'm going to multiply every term in it by 3, and I'll explain why in just a minute. Or actually, excuse me, let me go ahead and multiply everything by negative 3. Negative 3, I'll explain that in a second. First, let's do the multiplication. So I distribute this to every term, right? So positive 21x, because a negative 3 and a negative 7 make a positive, minus 3y equals, and I don't know what 3 times 19 is off the top of my head here. Yeah, well that's actually easy. So that gets me a positive 57, right? So here's my new equation. This is new. And if you take a look at this, if I was to add this new equation with my bottom red original equation, the y's would cancel out. Check it out. Let me show you. So negative 2x plus 3y equals negative 19. If I add these together, I get 57 plus a negative 19, or 57 minus 19, right? So what would that be? Would that be, I don't know, 38, right? And these y's cancel out because negative 3 plus 3 is 0. So I have 0y, and over here now I have 19x. So now I have the statement, and I'll write it over here because I'm running out of room, that 19x is equal to 38. because 0y just goes away, right? 0y is nothing. So now if I continue to solve this for x, I get that x is equal to 2. So what I've done is I chose to multiply everything in this equation by -3, the top equation, because I knew that if I could get a -3 coefficient on the y, if I was to add both equations, my y's would cancel. I could have done something similar to cancel out the x's, but nothing really worked nice with the 7 and the 2. Also, if you're stuck and you can't just multiply one equation by one number, you can multiply both equations by different numbers to get a common coefficient. Anyways, now that I know that x is 2, if I plug that into any one of these equations, it'll give me y. So, for example, if x is 2 in this red equation here, if x is 2, I'll write over it, that gets me -4 plus 3y equals -19. And I'm kind of out of room, so let me shrink this stuff real quick. Okay? So that would be -2 times 2 plus 3y equals -19. So -4 plus 3y equals -19. And then I have to add 4 to both sides. I'm solving for y now. That equals -15. Now I divide both sides by 3. So now y equals -5. So now I've said, hey, my point of solution is going to be a value of 2 for the x and -5 for the y. And I use the elimination method to do that. There's a lot to this method. We're going to look at it in class even further. But I'm expecting you just to take notes and to be ready to discuss it in class. Thanks for watching this example. I've got one more quick one for you. Okay, so again, we can multiply any equation by any number. So the thing that I'm going to do, and you can approach this differently, but I'm going to try to eliminate x's this time. And I see that, if I multiply everything in this equation by a number, it's going to be kind of hard to get -5, right? I have to multiply by a decimal. So what I'm going to do is I'm going to multiply this equation by 5. I'm going to multiply this equation by 2. And what that's going to do is it's going to get me -10 right here in the x on the right, and it's going to get me +10 right here. So when I add them, they'll cancel out. So again, you can multiply both of your equations by a number with the intent of getting the integer opposite. So 10 versus -10. This is going to become 10x, and this is going to become -10x. So let's do the math. I'll multiply everything in this red equation up here by 5. So I get 10x plus 40y, whoops, I forgot my x there, equals 30. And over here on the right, I'm going to multiply everything by 2. So I get -10x minus 40y equals -30. So now if I stack these equations and I add them together, something very interesting is going to happen. Now this won't always happen. I chose this example on purpose, but let's just see what does happen. So 30 minus -30, or 30 plus, sorry, we're adding these equations. So 30 plus -30 is 0. This goes out to 0y, and this is 0x. So we essentially have 0 is equal to 0. And that leaves us with the question of what does that mean? We haven't done anything wrong mathematically. We multiplied everything by the same number here and everything by 2 here on this equation right here. Then we added those equations together and everything got eliminated. Well, if everything gets eliminated, you might have noticed that it really means they're the same equation. Because if I was to multiply the blue equation again, but this time by -1, so if I was to multiply by -1, sorry, let me write that correctly. If I was to multiply this by -1, it would change the sign of everything, and so it would come down here and look like 10x plus 40y equals 30, which is the exact same equation I have right here. And so obviously if they're the same equation, it means they're the same line. So if your equations default down to 0 equals 0, or simplify down to that, that indicates you have infinite solutions. Infinite solutions. Using the elimination method, when you subtract, you'll end up with 0 equals 0. Or I'm sorry, when you add the equations together. So that was an example, and I have one little challenge question for you, and then this video is done. So the last thing I want to leave you with is sort of a challenge, and that challenge would be, what happens when using the elimination method and a system has no solution? What is going to happen to the equations? So what are the equations going to do? Okay, what are the equations going to do when there's no solution and you're using the elimination method to solve a system? We've already talked and looked at an example where there's infinite solutions. You ended up with like 0 equals 0, or essentially they were the same line, right? So what's going to happen to the equations if there's no solution, or if the lines are parallel? So maybe try to experiment with a set of parallel lines, drop some equations of, two lines that are parallel, and you try the elimination method on them and see what happens. All I want you to do tonight is watch this video and try that challenge, and come into class ready to discuss and learn the elimination method. Thanks, guys.